Okay, so moving on to question number 4, which just asks, define nonpolar covalent bonds. Okay, so let me just move this over. Nonpolar covalent bonds. This is when two atoms have equal or similar electronegativity values. Okay, so let me just underline it. So typically, in nonpolar covalent bonds, the difference in electronegativity between the two atoms, it ranges from around 0 to like 0.4. Okay, so some examples of nonpolar covalent bonds would be like diatomic gases such as N2 or O2. So obviously, since you have two of the same atom that are bonded together, they will have the same electronegativity. So obviously they just have a difference in electronegativity of just 0. And another common nonpolar covalent bond would be like the carbon-hydrogen bond. So let's just show up here how we can calculate the difference in electronegativity between carbon and hydrogen. Let's just search electronegativity values. See all the different values of these elements. So carbon has an electronegativity value of 2.5 and hydrogen has an electronegativity value of 2.1. So 2.5 minus 2.1 is equal to 0.4. So this lies within this range of 0 to 0.4. So this makes our carbon and hydrogen bond nonpolar. So now we can compare nonpolar covalent bonds with polar covalent bonds. And as you can guess, this is when you have two atoms that have dissimilar electronegativity values. Leading to a dipole moment. Typically, its electronegativity ranges as well. Greater than 0.5, but less than around 1.69. Okay, so let's look at some examples of polar covalent bonds. A common one is the hydrogen-oxygen bond. So again, let's try to calculate its difference in electronegativity. Oxygen's electronegativity is 3.5. and hydrogen's is only 2.1. So this makes this difference in electronegativity equal to 1.4, which lies within this range, making the OH bond polar covalent. Another example of a polar covalent bond would be like phosphorus and fluorine, or like carbon and oxygen. These are examples of polar covalent bonds. So you can distinguish whether or not something's polar covalent because covalent bonds is when you have the sharing of electrons between two nonmetals. And that's why this difference in electronegativity just kind of helps us distinguish whether or not a bond is nonpolar or polar, because we can also have something called an ionic bond. Which is between a metal and a nonmetal. So the minute you see that a metal is involved in the bonding, that's how you know you have an ionic bond. So even if you calculated its difference in electronegativity to be around like 1.68, we know that it won't be polar covalent because it contains a metal. But typically, its difference in electronegativity is greater than 1.7. So let's look at an example for ionic bonds, like potassium fluorine. Potassium is a metal, and fluorine is a nonmetal. And if we were to look up their electronegativity values, fluorine has an electronegativity of 4, and potassium's is only 0.8. So we get a really high electronegativity difference of around 3.2, making this potassium fluorine bond ionic. Okay, so now let's see what the junior tutor said. When the electrons of an atom attract the electrons of another atom, making this chemical attraction, it is called a chemical bond. It has two types, which are ionic bonds and covalent bonds. Ionic bonding is where the electron of an atom is donated to another atom, making an exchange and forming a bond. Ions are formed. We have positively charged ions, which are cations, and negatively charged ions, which are anions. Covalent bonding is where the electrons of the both atoms are shared between one another, forming a bond. It also has two types, which are polar covalent bonds and nonpolar covalent bonds. A type of covalent bond, a polar bond, is where one atom gains a partially positive charge while the other gains a partial negative charge, having unequal sharing. On the other hand, a nonpolar bond is where there is no charge separation, both having equal sharing. Therefore, and then I guess they summed it up. Yep, so this solution is correct. I'm just going to put the difference in electronegativity value that might help distinguish between polar and nonpolar covalent bonds. Okay, so I just put some examples of what these differences in electronegativities might be. Here I should define En. Okay, so this solution is correct.